Yeah, the exercises on page 353 make it more difficult. Instead of just a simple series, they give you bits and pieces. They give you certain variables, like they give you the sum of the 20th term, up to the 20th term. So there's the first term, and there's the value of the 20th term, and they're supposed to figure out the sum given the first term and the value of the last term. And it's arithmetic term, so you're going to have to derive d, and you have to, well, you know that n is 20, so you're going to have to use the stuff that you know, plug it into a formula, and find out the stuff that you don't know. So the first 6 are all like that, relatively simple, so I'll show you A, C, and E. First of all, A, they give you, well, first of all, before we do anything, let's put our little toolkit here. Make sure we can see all that. There it is off to the side. Okay, so those are the formulas that we use. We're going to see what we know here given in the text, and if they tell us this stuff, we're going to just calculate the missing value. Remember that Tn is the value of term in position n, whatever that position is. So if you are given a term 20 or something like that, it will equal this stuff here, right? And that would be n would equal 20, right? If it's term 20. And these are sums. This is adding everything up to that particular term, and so we just have to pick the right formula, plug in the data. So let's look first at 2a. 2a, you want to find the sum of 20. Sum up to the 20th term. That's adding all the terms together up to the 20th one. A1 equals 8. A20, or the 20th term, equals 65. So we know the last term, we know the first term, we want to find out the sum. We also know n, because there are 20 terms. There might be more terms in the sequence, but we only care about the sum up to the 20th term. So what we're looking for then, because we know the last term and the first term, and we know that there's 20, we're looking for this formula here, which is just sliding out. There we go. That formula, really straightforward. So S of n equals n over 2 times a plus l. The key here is to recognize that they've given you a, l, and n. So it's a simple matter of plugging those things in. There are 20 terms. The first term is 8. The last term is 65. So the sum, therefore, is 10 times this business here. 8 plus 65 is 73. And I say 10 times because that's 10, right? So 8 plus 65 equals 73 times 10 equals 730. That was easy, relative to the rest anyway. So let's look at 2c. 2c gives us asking for the sum up to the 56th term if the 56th term equals 13, and d is negative 9. So now they're giving us d, they're giving us the 56th term, and they're asking us for the sum. So, looking at our toolkit again, they've given us d. We know that there are 56 terms, so we know what n is. We do not know what a is. We do not know what the sum is. So, we know d. We know n. We know this, the value of the 56th term. So if we know the 56th term, which is 13, we know d is negative 9, we know there's 56 terms, we can derive a by using this formula. And once we've derived a, we will know a and n and d, which will allow us to use this formula to calculate S of n. So this is our first one here. Our first step then is the term equals a plus n minus 1 d. So the 56th term, or a56, is 13. It gives us that in the text. We don't know what a is, that's what we're going to derive. We know that there's 56 terms, and it's multiplied by minus 9. So we solve this for a. Quick math here, so 13 equals a plus, this is a multiplication there, so 55 times minus 9, oh boy, 55 times minus 9, 55 times minus 9, that's going to be a negative number. 50 times 9 is 450, 5 times 9 is 45, we add that up, 495, 495. So a minus 495, a minus 495 equals 13. A must equal 508. And so if a equals 508, I'll make my a's look like a's instead of 9s. There we go. So a still looks like a 9. A equals 508. We now know what a is. We know what d is. We know what n is. We're in business. We can use this formula. So let's start writing that out. It was 56 terms, correct? So 56 over 2 times 2a, so 2 times that, which is 1016, plus n minus 1, which is 55, times d, which is times negative 9. Negative 9. 55 times negative 9 we already know, so let's simplify this a little bit. This is s of n, by the way. So 56 over 2 is 28 times, well, 55 times minus 9, we already determined 495, so that's 1016 minus 495 equals, wow, this is getting to be a big number. That's 516, 521, so 28 times 521, and I don't know what that is, and I don't care. You can figure that one out. Equals something. Looks to me like around 14,500-ish. I'll leave that one to you in your calculator. Let's look at E. So this is 2E. And 2E says find D. Find D. And we know that S40 equals 680 and A1 equals 11. So we know S of 40 equals 680. We know that A1 equals 11. We know that N equals 40. We don't know what L is. Doesn't matter. We need to find out D. So if we can figure out L, we can use L because L would then become Tn, and we could figure out D from that. So let's go about figuring out L. Let's use this formula to figure out what L is. So the sum of 40 is going to equal n over 2a plus L. So 680 equals 40 over 2, which is 20, times 11 plus L. So let's divide both sides by 20. We get 34 equals 11 plus L, and L then equals 23. So if L equals 23, L therefore becomes the last term. The last term being Tm, term n. So that would be the 40th term. So term 40 would equal a plus n minus 1 d. So term 40 is 23 equals the first term, 11, plus n minus 1 is 40 minus 1 is 39 d. So we can solve for d. Not easy, but let's subtract here. That's 12 equals 39d. Divide both sides by 39, we got 12 over 39 equals d. And I know it's an ugly fraction, but that's the way it is.